Alright guys, these next few topics that we have to go through are going to be incredibly important for our next chapter, which is dealing with quadratics. More specifically, the next lesson. This lesson we're kind of going back to exponent laws and exponent rules, but instead of dealing with integers and whole numbers, we're going to be dealing with rational exponents, so fractions. And it may seem kind of weird at times because we're going to be going from one way of writing it to another way. That's what today's lesson is all about. We're going to start with one way, how it looks, and we're going to end up and transform it into something else. And we're going to go back and forth. Okay? So let me get some basics out of the way before we start transitioning from one form to another. You guys are very used to hearing the term square root. I mean, if I ask you for the square root of 81, you can tell me that it's 9. Because again, what the square root says is, alright, what number times itself, or what number multiplied by itself is 81. Some other things that you may not know, there are two ways to get to 81. 9 times 9, and negative 9 times negative 9. So the square root actually has two meanings when you take the square root of something, and that's a concept we'll go deeper in when we start solving quadratic equations, which is very shortly. But that square root sign is also called something else, and it's called a radical. The square root is a very specific type of radical because we're asking ourselves what number multiplied by itself is 81. So something times something. All right, that's two somethings. Radical is the more general term, and it encompasses all the different types of roots. For example, you could have the cube root. What number multiplied by itself, so 3 somethings equals the number underneath. We could have the 4th root, we could have the 5th root, we could have the 6th root, so on and so forth. So a more general term that I'm going to use from here on out is I'm just going to call them radicals. Okay? This right here is a perfect example of what a radical looks like. This is the radical sign. It looks like a somewhat long division sign, but in essence it's a radical sign. This number right here, it belongs inside this little valley, I guess, the valley of the radical sign, if you want to call it that. This is called the index. And the index tells you what root you have. So for example, in this radical, the index is 3. That means we have a cube root. If the index was 4, we have a 4th root. If the index was 5, we'd have a 5th root. So you're probably wondering or asking yourself, Mr. Z, then when I have a square root, if I take the square root of 25, why is there no index there? Why is there no number inside the valley? Just like with other things in math, guys, if we don't put a number there, it's assumed that it's there. For example, if you have x, we know that this is 1x. We don't write the 1, okay, but the 1 is assumed to be there. For exponents, if I don't have an exponent, it doesn't mean it doesn't have an exponent, it just means that 1 is there. And we don't write the 1 because it's assumed that it's there. So again, if we don't write it, we're assuming it's there. Same concept for radicals. If we don't write a number here, it's not 1, it's 2. Because again, the lowest root possible is going to be the square root. Just like 1 is the lowest number possible. So again, since there's no number here, we're assuming this is a square root. Can you write 2 there? Yeah, of course you can write 2 there if you really want to, but you don't see me writing 1s for exponents and 1s for coefficients. So again, whenever you see no number inside the little valley, assume that it's going to be 2. Assume it's a square root. Alright? One more term, well, 2 more terms. You guys already know that this is called the power, or the exponent. And finally, this right here, or this entire term together, whatever is underneath the radical is called a radicand. And for the most part, I'm going to be saying, all right, what do we have underneath the radical? But if I ever say radicand, I'm talking about everything underneath the radical. So it is a term I'll be throwing out there once or twice. No, I'm not talking about Pokemon. I'm not talking about radicate. I'm talking about the radicand. Little math joke. I know you're laughing. Alright guys, so you have the basics out of the way. Now we're going to be transforming different terms to look somewhat, well, different. For example, rewrite x to the 4/3 using radicals. We can take rational exponents and we can rewrite them to look like radicals. Okay, that's why I never used rational exponents. That's why I never used fractions when we dealt with exponent laws, because there was also something else to them. All right, so I'm just going to tell you how to do it, and you're going to do it. This is more procedural than conceptual. All right, there is no underlying concept that you have to master. All right, it's all procedures. So just understanding how to do it is good enough for this topic right now. Okay, so it says rewrite x to the 4/3 using radicals. If I want to take this and I want to rewrite it as a radical, that means it's no longer going to be an exponent like this. Okay, so x to the 4/3, this fraction actually means something. Okay, this fraction actually means something. This 4 tells me my power. This 4 will, or the numerator, will always be the power for my radicand. Okay, or the term underneath the radical. The denominator always tells me my root. What type of root do I have? Do I have a 4th root? Do I have a cube root? Do I have a square root? What is it? All right. So again, the denominator tells me my root. So that's going to be the index. It's going to tell me my index. So simply put, if I'm going to rewrite this, I write my radical. I know I need a root of 3. I know I'm going to have an exponent of 4, and obviously my term, x. And that's it. I mean, there's nothing else to it, okay? One thing I do want to point out, you can write this with the 4 on the outside. It doesn't make a difference how you write it, but you can write it with the 4 on the outside. So you may see it either way, and you're not wrong no matter how you write it. Just understand that the numerator is the power, and the denominator is the root. It's your index. Okay? Same concept for going the other way. So I have the square root of x to the 7th. I know this is going to be my numerator, and the index is going to be my denominator. Mr. Z, there's no number there. What do I put? Do I put a 1? No, you don't put a 1. Remember, guys, 4 square roots. Since there's no number there, we're assuming there's a 2 there. So again, this is going to be my denominator. Numerator, denominator. So I'm going to write my radicand, which is just x in this sense, to the 7 over 2 power. So the 7 has power. Okay? Again, nothing crazy. We're not solving anything, all right? We're not even really simplifying anything. We're kind of just rewriting terms right now. And that's what today's going to be all about, practicing going from one way to another. Now, I haven't given you many examples, so if you guys are still confused, you can just keep watching as I go through these next practice problems. But if you kind of get it on your own, attempt these next practice problems yourself. We're only doing the front side of the notes today because after we finish this front side, you guys will practice over and over again, rewriting these terms from one to another and vice versa. And tomorrow we'll actually finish the back side of the notes because simplifying radicals is going to take some time. Okay, but let's get this basic foundation down, and then we should be good to go. So again, you can hit the pause button. You don't have to keep watching if you want to try it on your own. I'm going to continue on and go through these quickly, so we should be good to go. So, first one, 4x to the 1/3. Now notice, I'm raising everything to the 1/3 power. Since I'm raising everything to the 1/3 power, I'm going to put everything underneath the cube root. Remember, this is my power, and this is my index, or my root. So I'm going to have a cubed root. Since 4x is inside my parentheses, that means the entire thing goes underneath the cube root. And I'm going to have a power of 1. Now, I don't have to write the 1, because if I don't write anything, it's assumed to be there. Mr. Z, what happens if it's not 1? What happens if it's 2? What happens if it's 3? What happens if it's 4? If you guys have a power that's larger than 1, you can just use parentheses, put it there if you had a power of 4. But again, make sure you're grouping these things with parentheses properly. Okay, don't mess that up. Same concept here. Everything is in parentheses. I know this is my power, and I know this is my root. So I'm going to have a fifth root right now. I'm going to have a fifth root of 3xy cubed. Not the y cubed, not the x cubed, not the 3 cubed. Everything's going to be cubed. Now, technically, this is not simplified down. To be correct, you'd actually have to, well, raise everything to the third power. So 3 cubed, x cubed, and y cubed. 3 cubed's easy. 3 times 3 times 3, which is 27. X cubed is just x cubed. Y cubed is just y cubed. So that's what that would look like simplified down. Now, pay attention to this next example because notice how it's slightly different than the last two. The last two, we were using parentheses to group everything together, which meant we were raising everything to that power on the outside. This third example does not have parentheses. So do not get it twisted. The 7 is not grouped with the x. That means the 7 does not have that exponent. Okay? It's not 7 to the 4/3, it's just 7 times x. X is raised to the 4/3 power. So in this case, guys, you don't put everything underneath the radical. I know I'm going to have a power of 4. I know I'm going to have a root of 3. So I'm going to have a cube root of 3. Again, only x is raised to the power. So x goes underneath, and x gets a power of 4. Mr. Z, where does the 7 go? Let's place it outside. So it's 7 times the cube root of x raised to the 4th power. That may look weird, guys, but again, since the 7 is not part of that power, since the 7 is not grouped inside parentheses, the 7 cannot go underneath the radical. So please don't make that mistake. If there's any difficult part to this besides remembering which one's the power and which one's the root, it's going to be understanding which one or what terms stay on the outside of the root or the radical and what terms stay on the inside of the radical. But that's it. I mean, going back and forth, guys, it's just going to take practice to get used to. So don't get discouraged if you're like, I don't know what's going on. Just try your best and we should be good to go. Number 4, rewrite each radical as a base with a rational exponent. And guys, I say rational instead of fractional. You can say fractional exponent, but rational numbers are basically any number besides irrational numbers. So rational numbers are repeating decimals, they're terminating decimals, they're also fractions. So rational is just a broader term for fractional, okay? So remember, if I want to convert this, everything is underneath. So I'm going to have my power, but I know, actually, that's my numerator, because we're now converting to rational exponents, and this is my denominator. I'm just going to write n and d because I'm not writing everything out. That takes way too long. So it's my denominator. So x, numerator, denominator. Done. That's it. There's nothing else to it. Now, again, notice here, I am not using parentheses to group the 5 and the x. Okay? That means that 5 is not raised to the 4th power. Only the x is. So altogether, my numerator is actually only 1. Because again, if I'm grouping these things together, only the x is raised to the 4th. So the entire thing is raised to the 1st. That may sound confusing and you guys may have questions about that. But again, only the x is raised to the 4th power. My root is 2. That's my denominator. So I'm going to have 5x to the 4th. This entire thing is going to be raised to the 1/2 power. Now, to simplify this even more, guys, you can distribute this. You can say 5 to the 1/2, because again, we multiply. And 4 times 1/2 is actually 2. You don't have to do it that way. That still looks kind of ugly, but as long as you remember your exponent laws, I mean, it's pretty straightforward. It shouldn't be too difficult. But again, the big picture with this one, guys, if you're confused, Mr. Z, why didn't we put a 4 up here? It's because only the x was raised to the 4th power, okay? Not the 5. So since only the x was raised to the fourth power, we cannot put the 4 as a numerator because it's not the power for the actual radicand. Okay, so that's why 1 is. Again, if you need clarification, just let me know. Hopefully I can make it sound better than it did just right now. Last one. The fourth root of xy raised to the negative third power. Now, if we're going back to exponent laws, guys, I included this question in here because I wanted to review. Remember, we can't have negative exponents. What does it mean when you have a negative exponent? Think about it. Negative sign means you flip over the line. So, since I have a negative 3 over 1, this negative 3 is going to cause me to flip everything down below. So I'm actually going to have 1 over the fourth root of xy cubed. Okay, so again, all I did was flip the location because negative exponents cause me to change whether it's in the numerator or in the denominator. Again, the 3 is on the outside, meaning everything is raised to the third power. And of course, I have the fourth root, so this is my denominator, this is my numerator. So I'm actually going to have 1 over parenthesis, because everything's being grouped together this time, to the 3/4 power. And that's it, guys. There's nothing more than that. Pretty straightforward lesson. But again, to really master these concepts, you guys are going to have to learn or just work on them over and over again. All right, so the notes are done for today. There should be some links for you guys to work with in the Google Classroom just to get used to this process going back and forth. Again, repetition is going to help tremendously. All right, so video's done. We're not doing the backside until tomorrow. Hopefully you guys got this. I'll see you later.